we've talked about the idea of central tendency. We've taken a look at five-number summary, mean, median, mode. We've taken a look at box plots. And we started hinting on the idea of dispersion, how spread out the data is. And sometimes we need a better measure of, well, it looks like it's more spread out or less spread out, or it's kind of spread out. We need some sort of more definitive way to describe the spread of data. And that's what standard deviation is. Standard deviation is the numerical measure of spread, and it's with respect to the mean. Essentially, if you have a higher standard deviation, that means that you're going to have a higher spread of data. And of course, if you have a lower spread of data, that means it's going to be a lower standard deviation. The idea of standard deviation helps us to kind of conceptualize the idea of reliability. Reliability basically meaning that the data is consistent. All right, so a lower standard deviation means more predictable data. A higher standard deviation means less predictable data. So our goal is to be able to first compute standard deviation and then maybe to be able to compare them and to be able to interpret. Just in general, standard deviation is one of the most important measures in statistics. Okay, we're going to be taking a look at standard deviation throughout the course. So for today, what we're going to be doing is just learning how to compute. Right? So there's two types of standard deviation. One is the population deviation, and we have this variable sigma. Sigma is just used to be able to represent the population standard deviation. To be able to compute it, now remember we have this sum of, so that's the sum of, remember x sub I is observations, and then mu is the population mean, right? So basically what we're going to do is we're going to subtract the mean from each of the observations, we're going to square it, and then we're going to divide it by capital N if we were doing the population standard deviation. Now N, remember lowercase n is sample size. This means population size. The good news is for us, I'm never going to ask you to compute this. You will have to know what sigma means, but very rarely in real life do we ever compute the population standard deviation. Okay? Most of the time it's just given to us. All right, so just making sure we understand like what those symbols mean. All right, now sample standard deviation though, I will ask you to be responsible for and to be able to compute. All right, so let's go through and talk about what that is. Sample standard deviation is denoted by S. Right, so whenever you see S, that just means sample standard deviation. And we have basically the same formula in which we're going to subtract each of the observations, the mean from that. All right, so we have, remember, X bar is the mean of the sample. And we're going to subtract each of the observations, the mean from that. We still have a sum of, we're going to square it, and then we have n minus 1. Okay, so let's go through and just do an example of this, so that way we can see the mechanics necessary to be able to compute this. All right, in general, it's a little bit tougher to compute sample standard deviation than other sorts of measures thus far. We just have a random list of numbers, and let's go through and try to find the standard deviation of that random list of numbers. The first thing we need to do is we need to find the sample size n. In this case, n is going to be 7. 1, 2, 3, 4, 5, 6, 7. Nice and easy. The next thing we need to do is we need to find x bar. And remember, x bar is just going to be the average. So we're going to take 13 plus 15 plus 21 plus 25 plus 27 plus 30 plus 31, and then we're going to divide that by 7. We're going to use our calculator to do that. All right. So that's going to be 13 plus 15. Oh, it wasn't. And we end up with 162. We're going to take that answer, divide it by 7, and we end up with 23.143 as our mean for the sample. All right, so just to make sure we understand how we got that, that's 162 divided by 7, which was 23.143. All right, so that's step one if you were kind of thinking about this. All right, you always want to do what's in the parentheses first. In this case, we computed x bar. All right, now we have to compute x sub I minus x bar. And what that means is that we're going to take all 7 of those observations, so 13, 15, 21, 25, 27, 30, and 31. And from that, we're going to subtract the mean. And so that's going to end up being our 23.143. And now you can see that this is pretty taxing to do by hand. And we're just going to use our calculator. Right? Now I'm going to do the first 1 or 2, and then I've already computed the rest of them beforehand. So in your calculator, you're just going to take 13 minus 23.143, and that's going to give us negative 10.143. It's okay to get a negative number. Right? So that's negative 10.143. And we could just continue this pattern, negative 8.143. This is going to be negative 2.143. This is going to be 1.857. All right, so notice that we get a different tenths, hundredths, and thousands place because now the first digit's bigger. And if you don't trust me, 25 minus 23.143. And that gives us the 1.857. All right, and we're just going to keep doing that right down the line. All right, so hopefully you understand where these numbers are coming from. We're just computing them by subtraction. So this is 3.857 and 6.857, and then finally 7.857. All right, now, so now what we've done is in our formula, we've done each of the xi minus x bars. All right. The next thing we have to do is we have to square each of those. All right, so now we're going to square each of these numbers. So this is going to be x sub I minus x bar quantity square. So we're just going to take negative 10.143 and we're going to square it. All right, now in your calculator, if it's a negative number, make sure you put it in parentheses. So we're going to do parenthesis negative 10.143. And then we're going to square that number. That gives us 102,880. So, and then we're just going to go right down the line, and we're just going to keep doing that over and over and over again. So 66.308, and then we have 4.592, and then 3.448. And so again, all I'm doing is I'm just squaring each of the numbers. All right, so just to, again, to illustrate how to go from here to here, all I'm doing is I'm just taking 1.857 and then I'm squaring that number. All right, and that gives us that 3.448. Okay, so again, all we're doing just squaring each of the numbers to get to each of those. Okay, all right. Next one that we have is going to be our 14.876, and then we're going to have 47.018, and then we finally have 61.732. All right, now, after we're done squaring each of the numbers, the last thing that we have to do is we have to get a sum of this. So what we're going to do is we are going to add up this column. Okay, so we are going to get the sum of all x sub I minus x bar squared. Right? And that just means we are going to add all the numbers in this column. Right? So in our calculator, we're just going to do, and I'm not going to do all of them, but we're going to do 102.880 plus 66.308, etc. And it should be 66 point. Right. And there we go. Now that's not the real answer, okay, but we would just go through and we would keep adding those up, so dot, 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 all right, and just keep doing that. All right, so just to illustrate what we end up with, you would go through and eventually you would end up with 300.857. All right, now that is the sum, but that is not the standard deviation. Okay? The standard deviation is this formula. Okay, we are almost done with this. Okay, so hang in there. Standard deviation is this formula right here. So we're going to take the number that we just got, divide it by n minus 1, and then put it in the square root. Okay, so for S, which is our sample standard deviation, that's the square root of 300.857 divided by 6. And how do we get 6? That's n minus 1, or 7 minus 1. Finally, we're going to put this into our calculator. So we're going to have second square root. We have our 300.857, and we're going to divide that by 6. And we get 7.081, and that is our standard deviation. Okay, so 7.08. And the question is, okay, well, what does this number really mean? I mean, it was pretty difficult for us to get to, but how do I interpret it? All right, and that's what we're going to learn later in the course. Right now, we're just going through, we're being able to compute the standard deviation, and then later we're going to be able to apply it. All right, so a suggestion. At this point, maybe go ahead, stop this video, try to work through this problem to find the sample standard deviation, and then watch the video and kind of follow along to see if you got it right or if you made an error where you might have made that error.